viewers, good afternoon. Myself Arvinderjit Mehmi, lecturer in production engineering from Government Polytechnic College, Amritsar, and the subject assigned to me is tool engineering. As you know, this subject consists of basically two parts. One is press working operations and second is jigs and fixtures, and the topic assigned today to me is just introductions towards jigs and fixtures. So first of all, let me tell you what is meant by jig and what is meant by fixture. These jigs and fixtures are basically special purpose tools which are used to facilitate production when workpieces are to be produced on a mass scale. The mass production of workpieces is based on the concept of interchangeability, according to which every part will be produced within an established tolerances. Jigs and fixtures provide a means of manufacturing interchangeable parts since they establish a relation between the work and the cutting tool. They eliminate the necessity of special setup for each individual part. So, from this introduction, it is very clear that these jigs and fixtures are some tools which are used in manufacturing processes for producing interchangeable parts. And when we use these jigs and fixtures, the individual settings for individual parts is eliminated. Once a jig or fixture is properly set up, any number of duplicate parts may be readily produced without additional setup. Now, jigs and fixtures are used, number one, to reduce the cost of production. Now, when we use jigs and fixtures, these help in eliminating the layout of work and setting up of tools again and again. Once the setting has been done, then production goes on. So, it reduces the cost of production. Secondly, it helps to increase the production. Third, it helps to assure high accuracy of the part, because a worker does not set the tool and workpiece again and again. Some partial automatic operations are there with the when we use these jigs and fixtures. So, this assures high accuracy of parts. These helps to provide for interchangeability. Next, to enable heavy and complex shaped parts to be machined by being held rigidly to a machine. With the help of these jigs and fixtures, very complicated parts, or you can say heavy parts, can be machined very easily when we use jigs and fixtures. Next is reduced quality control expenses. Once the jigs and fixtures has been set up, then there is very less requirement for checking its quality, because when we incorporate jigs and fixtures, then process partially becomes automatic. Next, increased versatility of machine tools. With the help of these jigs and fixtures, a machine can be used for number of operations instead of one operation or two operations. So, increased versatility of the machine tool is there. Next, less skilled labor is required, because when we incorporate jigs and fixtures, even unskilled worker can perform machining operations, because with the incorporation of jigs and fixtures, partial automation is there. Next, saving labor. Next, their use partially automates the machine tools. Now, again, uh, let me tell you particularly what is meant by a jig and what is meant by a fixture. A jig may be defined as a device which holds and positions the work, locates or guides the cutting tool relative to the workpiece, and usually is not fixed to the machine table. It is usually lighter in construction. So, jig is a device which particularly holds and position the workpiece, as well as it locates or guides the cutting tool relative to the workpiece, and these jigs are relatively lighter in constructions as compared to uh, fixtures. Now, a fixture is a work holding device. Mind it, jig is a work holding as well as locating device. At the same time, a fixture is a work holding device which only holds and position the work, what does not in itself guide or locate or position the cutting tool. And this is the main difference between the jig and fixture. In case of fixture, these tools only holds or position the work, whereas jig is a device which hold or position the work. At the same time, these jigs locate or guides the cutting tool. The setting of tool is done by machine adjustment and setting block, or by using slip gauges. A fixture is bolted or clamped to the machine table. It is usually heavy in construction. Jigs are used on drilling, reaming, tapping, counterboring operations, while fixtures are used in connection with turning, milling, grinding, shaping, planing, and boring operation. So, jigs are used for lighter operations, and fixtures are comparatively used for heavier or heavy operations. And because jig is jig is really not clamped to the table of the machine, whereas a fixture which is heavy in construction, it is always clamped or bolted to the machine table. To fulfill their basic functions, both jigs and fixtures should possess the following components or elements. So, to fulfill their basic requirements, the jigs and fixtures should have the following component parts. First of all, it should have a sufficiently rigid body. Body may be in the form of plate, box, or a frame structure into which the work pieces are loaded. So, jig or fixture, whatsoever it may be, it should have a rigid body into which the workpieces are to be loaded again and again. Secondly, it must have some locating elements so that workpiece can be located in different directions. Thirdly, these jigs and fixtures must have some clamping elements so that workpiece can be clamped or locked in particular directions on the machine. It must have tool guiding elements because in case of jig, tool must be guided, so it must have some guiding elements, and in case of fixture it must have some tool setting elements. Elements for positioning or fastening the jig or fixture on the machine on which it is used. Now let's talk clearly what is the use of jig or fixtures. Suppose 4 holes are to be drilled in a rectangular plate. What operations you require to get the 4 holes drilled in a plate are as follows. First of all, what we do, we spread the solution of chalk on one surface of the plate and let it dry for some time. Then mark the centers of the holes by some pointer. Then hold the plate of the machine and then drill the holes. A great care is required when the drilling operation is being done. The holes must be exactly in correct position where the centers are marked, and the centers must be marked in the correct position. As you can see on your monitor, we have a figure of a job in which 4 holes are to be drilled. So what we do in this case, when we do not use jigs and fixtures and we are to drill 4 holes in a plate, what we do, first of all, we apply a solution of chalk on one side of the workpiece. Then centers of the holes are marked with some pointer and this plate is brought under the drill and 4 holes are drilled one by one at the marked points. So this is a very tedious process. It requires a great care and more time, which cannot be given in the manufacturing companies where time is money and labor is poor. Even then, it is possible if we are to produce 1, 2, 3 or 4 plates in which 4 holes are to be drilled, even then it is possible. What suppose we are to produce 1000 plates, then what will happen? Then this particular process may not be feasible when we are to produce thousands and thousands plates. Suppose if 2000 plates are to be drilled, a lot of time will be required and also a number of workers will be required to perform all these operations before drilling. What drilling may be done quite easily with less care and labor within a less time by means of jigs and fixture. Now in case of mass production, drillings can be done with less care and within less time. When we use jigs and fixture, now on your monitor you can see this is our job, rectangular job, in which 4 holes are to be drilled. For this job, what we do, we prepare a jig. This is the sectioned portion shown, and this is the top view of the jig plate. What we do, we make 4 holes, similar 4 holes which are as in the job. We produce these 4 holes like this, 1, 2, 3 and 4, and in these 4 holes we insert 4 bushes. The inside diameter of the bushes should be slightly more than the holes required, so that drills can move in these holes. And these bushes are spot welded from this side as well as on this side. As shown in figure, 4 holes are drilled very accurately in plate of job size. Bushes are inserted in the holes and spot welded. The inner diameter of the bush is slightly larger than the hole to be drilled to take the drill inside. This device is called drilling jig. It is kept over a number of plates and clamped with them by means of another device which is called a drilling fixture. The holes are located on the jig accurately, which guide the drill. Thus, we do not require to mark the centers of the holes on each plate and to drill them one by one. Simply put the drilling jig on a number of plates, clamp them and insert the drill through the bushes of the jig. Holes can be drilled in 2000 plates quite easily and within a less time. Hence, jigs and fixtures facilitates the operations and increase the production. Jigs and fixtures are usually designed in a tooling department by tool designer. The jigs and fixtures are named according to the operations they are going to perform. If there is drilling, then jig and fixture may be called a drilling jig, a drilling fixture. If they help in the operation of welding, then these jigs and fixtures can be called welding jig or welding fixture. If these jigs and fixtures are used in forging, then these jigs and fixture may be called a forging jig or a forging fixture, facing jig or facing fixture, extra. So these jigs and fixture named after the operations they are going to perform. Now the factors of designing the jigs and fixture. What factors are there in the design of the jigs and fixture? First of all, the following factors must be considered while designing the jigs and fixture. First is clamping. Now clamping means holding the job in a particular position. Now this clamping system of jig and fixture with component should be easy and simple. It depends upon the shape of the jigs and fixture. The clamps should be placed immediately above the supporting points to avoid distortion and should be operated from the front of the machine to avoid obstruction. Then clearance. The second factor is clearance. Now the jig or the fixture must have sufficient clearance for operating the tools and removing the chips. So sufficient clearance should be there so that if there is accumulation of chips, then these chips should be removed easily. Blind spots and corners for the chip accumulation should be avoided. Generally, the chips are carried out by the coolant to clear the work and the jig or the fixture. Third factor is design. Jigs and fixtures are so designed that they may be able to withstand ill uses without losing accuracy. Swinging parts should be properly balanced. Most economical design of the jigs and fixture will be liable to take every machining operation. And here the previous experience of the designing jigs and fixture is of considerable importance. A great attention should be given to store and lift the jigs and fixture. And the fourth point is handling of the jigs and fixtures. If the jig or fixture is of small size, then attention must be given to its weight. Heavy jigs and fixtures should have eye bolts or lifting lugs for the lifting purposes. So if the jig or fixture is of small size, then attention must be given to its weight. And for carrying jigs or fixture which are heavy in nature, so to carry the jigs or fixture from one place to the another place, some bolts or lifting lugs should be there for their transportation. Then fifth point is loading and unloading. Loading or and unloading means loading of workpiece into the jig or fixture. If there is sufficient clearance, then loading of the jigs or fixture will be comparatively easy. If there is very small clearance, then loading and unloading will be somewhat difficult. So sufficient clearance will facilitate the jigs to handle easily. Short bearing surfaces should be arranged when locating on a diameter. A great care should be taken in loading and unloading the jigs and fixture. And the sixth point is foolproofing. The design of the jig and fixture should be so arranged that job cannot be placed incorrectly in it. What does it mean? So it means loading of the job in some incorrect way should not be there. The system should be such that these jigs and fixture should not allow the jobs in some wrong way. The incorporation of foolproofing peg will assist here. Seventh point is gauge and setting blocks. There should be some provision on each jig or fixture for setting blocks and gauges when they can be usefully employed. And eighth is locating pads. Wide bearing surface should be avoided to keep the jig and fixture free from swath and dirt. Only a few points by which the equipment is located will permit easy cleaning. 3 pinpoints are sufficient to locate the rough casting and forged surfaces. Long jigs and fixtures are supported by minimum points. And the ninth point is datum. Only a datum should be used to reduce the effect of accumulative errors, and it should be used throughout the whole process of manufacture. The best chosen datum will provide sufficient material for each operation in production cycle. If more datum are to be chosen, care should be taken to reduce errors. 10th point is machine. In designing the long jigs or fixture, the machine by which they are to be operated should be studied and noted their possibilities and limitations. The size of the equipment should be such that it can be accommodated easily on the machine. So, before designing the jigs and fixture, a designer must know what is the size of the table of the machine on which these jigs or fixture are to be clamped or placed. And 11th point is material. The material required for the jigs and fixture should be suitable and cheap. In essential parts, the special alloy may be used. Welded structure should be avoided where vibration is created during the operation. Good heavy cast iron base should be provided in such a case. Heat treated parts should be clearly noted. So, material of the jigs or fixture plays a very important role. As I have explained already, in case of if there are more vibrations, then welded structure is not suitable. In case of heavy vibrations, heavy cast iron base should be provided. And 12th point is safety. Every care should be taken in designing the jigs and fixtures to avoid the dangerous points. Sharp corners should be rounded. Holding points should be best located. Economic conditions. Attention must be given to economic condition when designing the jigs and fixture. Cheap and simple design is profitable. Some jigs and fixture are so designed by which a number of jobs are operated at a time. Single or multiple tools used, manual, semi-automatic or full automatic operations done, etc. are considerable factors in the economical conditions. So, in brief, the following principles are considerable in designing the jigs and fixture. The first point to be kept in mind is accurate location of production. Second, clamping the production. Third, selection of bushes of correct style and size. Fourth, easy and quick removal of production. Fifth point is economic conditions. Now comes the next is types of drilling jigs. There is no hard and fast criteria for classifying the drilling jigs. However, the drilling jigs may be classified as follows. First of all, template jig. This is the simplest type of drilling jig. It is simply a plate to the shape and size of the workpiece with required number of holes made in it accurately. A simple template type of jig is shown in figure. It is placed on the workpiece and the